So in chapter 3, we're going to look at some ways of collecting data, simulation, sampling, and some organization that you need to go and have to put together for running studies, web designs for your experiment, so you can keep track of the variables that you're looking at and how things are being done in your studies. Being organized for an experiment is just as important as the results of it, because without being organized, your results might not end up being valid. So 3.1 is understanding randomness, and what we're going to look at here is what randomness is and how, if we know something is random, what should be the outcome, and if that outcome doesn't happen, we're going to look at the results and see why didn't it happen, why wasn't it random. So randomness, not being able to predict beforehand. Equal frequency is important. So this is saying randomness is if equal frequency, every observation unit has an equal chance of being picked. Now with this randomness, one way of collecting data, sometimes you can't do the real life. You can't do what the study is actually looking at because of either money or just it not being plausible to actually put together. What you can do though is run a simulation. Okay? Simulation is basically modeling the study that we're looking for, and we have different ways that we can go through that, different ways that we can put together the randomness that would happen in real life or what should be happening in real life. Okay? Now this is on me using some random numbers, and there's a couple different ways you can get random numbers. Now, a long time ago, before we had the technology to generate random integers, we used something called a table of random integers. This was really a difficult thing to look at, and what you would do is you would look at one of the rows and you would just start going over, and depending on what numbers you're looking at for your simulation, you would just start going across the rows and picking out those numbers. If you were looking at 3-digit numbers, let's say your instructor might say, okay, you start on row 3. And if you start looking at the 3-digit numbers, you're looking at 104, 384, 448, and just keep going until you get the numbers that you're looking for. Luckily now, we have calculators to do this. There's computer programs that will generate numbers, and that's what we're going to be looking at. We're going to be using the technology to do the random numbers so we can do it quickly and look at the results. So what we're going to look at for the rest of this section is simulations. Okay? When you're running a simulation, there's going to be different things you're going to need to pick out that are going to help organize and show that you know what you're looking at. Okay? One's the component. Okay? The component is going to be the basic event. Each number that we're calling up, each integer that we call up, what does that one number represent? So that's almost like the observational unit. Here's our one value. What does that one value represent? Now, component goes along with the outcomes. Okay? When I ask you for the outcome, I'm not looking big picture, I'm looking small. What is that one outcome for that one component that we have? One number comes up, that's our component. What could happen with that one component? So it's a component, has a set of possible outcomes. So you're going to say it's either, whatever this number is, it's either yes or no. Okay? It's basically going to be the variable about that value that we're looking at. Trials. This is looking bigger picture. Okay? The trial is looking at how long we're going to run our simulation until we go to the next step. Okay? So each sequence of components, how many components are you going to have? And it's going to depend on your situation. We're going to do 2 examples in this video that you're going to have 2 different ways of running your trials and are knowing when a trial begins and when a trial ends. Okay? The response variable, again, is big picture. It's looking at a trial. So you can put component and outcomes together. Trial and response variables come together. Okay? The response variable is looking at the entire trial. So this is going to be our final recording that we did. Here's our trial, what happened in that trial, and that's what we're going to be writing down. Okay? So they're the 4 pieces that you're going to have to identify before you actually start writing the simulation. Okay? The other thing you have to think about is the actual numbers, integers that you're going to use, and things about the parameter of the situation that we're looking at. Suppose a basketball player has an 80% free throw success rate. Run a simulation and estimate how many free throws they can make before missing. So here's our parameters, 80%. So what we need to think about is, okay, how can we model this situation? Okay, we know they're shooting 80%. And we have to assume that's on the independent. This is someone who's been around for a while, so we know 80% is pretty solid, and that's not going to change. Okay? So when we think about how we're going to model this, okay, two things we need to think about is what integers are being used and what do the integers represent. So really what we need to think about is how can we make up that 80%? Okay? Right? There's a couple different ways you could look at it. Okay? We could use 1 to 5. Okay? 1 to 5 would end up working. That would be going through our situation, and we can make 80%. Okay? You can say 1 to 4 is a made shot, and if a 5 shows up, that's a miss. Okay? So that's one way you could do this. Okay? You could do 1 to 100. 1 to 80 being made, and then 81 to 100 being missed. You just need to be able to figure out a way, how can you split up the integers you're going to use to fit in that 80%? Now, one thing you have to be careful about is you have to be able to get your 80%. You couldn't use 1 to 4. 1 to 4 wouldn't work because there's no way to get 80%. So that's what you're going to need to watch for. How can I put together my integers so that it represents our parameter that we're looking at? Okay, so the next thing we're going to look at here is, okay, think of the process of calling up the integers, okay? We're going to be looking at how we're going to call up numbers. We're going to call it 10 at a time, 1 at a time, and that's what you need to think about after you think about the integers that you're going to use. Okay? So now let's think about the component, outcome, and trial and response of our values. Okay? The component here, that's what every number is going to represent, and each number represents one free throw. So if one number comes up, that's a shot that he took. The outcome of that, okay, we'll shoot a basket. You either made it or you missed the shot. But each number has that one situation, that one possible outcome. You either made it or you missed it. The trial in this case. So this is where you need to think about, okay, how long am I going to be calling up numbers for? Okay, we're looking at free throws he made before he misses. So we're going to be counting shots. He made it, he made it, he made it, he missed. Okay, it might go he made, then he missed. We don't know exactly how many he's going to do. So our trial this time, it's not a set number. Okay, one shot at a time until a miss. Okay, so we're calling up shot after shot after shot, and until you get that missed value, whatever integers you decide to use, that's when our trial would end. Okay, and the response variable, okay, it's the number of made shots until they missed. So we're looking at shots, and we're not counting. Okay, he made 5, he missed on the 6th, so 5 shots is how many he made. He took 8 shots, he missed on the 9th, 8 is how many he made. So this is looking at the entire trial. So again, here's kind of the pieces that you're going to need to put together. Now once you have these, this is where now in the assignment you'd be given, okay, seed your calculator to 50. Seed your calculator and start calling up numbers. Okay, this is where you'd have a table, organize your information, and go from there. Okay? So this is one example of a simulation. Okay? At the end, you always analyze the response and state your conclusion. In this case, we're counting numbers. We have 5 shots made, 3 shots made, depending on how many trials you did. Okay? This is quantitative data. Quantitative data, you would calculate the average, and you would say, we estimate the person is going to make between 5 or 6 shots. Finding the average of that. Okay? We know you can't make 5.6 shots. That 0.6 doesn't really go one way or the other, so you might say between 5 or 6 shots until he misses one. Okay? Quantitative data, you're going to find the average. Okay? You're going to find the average. Second example, 57 students sign up for a lottery for a particular desirable dorm room, a triple with a fireplace and private bathroom. 20 of the 57 are all on the same varsity sports team. People heard that the lottery may be fixed so that the 3 people are all from that one team. Run a simulation to estimate how likely it is that all 3 students are from that sports team. Okay? So we have 57 total students. 20 of them are on the same sports team, and we want to know, okay, if all 3 of them are on that sports team, is it going to be very likely to happen? Okay, so you're going to have to think through this and think, okay, how am I going to run this simulation? Okay, you're not going to sit here and just let it happen. You're not, and you actually can't do it. I'm sure these people aren't just on wait around. So we're going to run a simulation to see if it's going to work. How would it work out? How should it pan out? Okay, because if we get a high percentage of all 3 of them being on the same sports team, it's probably not fixed. But if we get a low percentage, if we run, say, 50 trials, and it doesn't happen where all 3 people are on the same sports team, most likely then we're not thinking, okay, if it does happen, something was fixed. Okay, so let's think about our situation here. Okay, so here we have the component, outcome, trial, and the response. Okay, I'm not even worried about the actual numbers that we're going to use yet. Okay, so let's look at the component, outcome, trial, and response. Our component this time, we call up one number. Each number is going to be a student selected. Okay, so that one number represents one of our 57 students. The outcome we care about, is that person on the sports team or aren't they? Okay, remember there are 20 people on the sports team. We're looking for people who are on it or are not on that sports team. The trial. Okay, the last basketball example, we called up numbers until something happened. So we were taking shot after shot after shot, and then the basketball player missed one. In this case, we have a set number. Okay, we know that dorm room has 3 people. Select students until 3 different students are selected. Okay, notice I made sure we said the different students here. Okay, we don't want to have the same person's not going to get picked twice to be in that dorm room. So make sure you have different numbers. Numbers cannot repeat within the trial. And at the end, we have our 3 different numbers. The question we're going to ask ourselves, were all 3 students on the varsity sports team? So you're going to say, yes, all 3 were on the varsity sports team, or no, all 3 were not on the varsity sports team. Okay? So the integers that we're going to use. We know 57 people signed up for this dorm room. Okay? So I'm going to use the integers this time, 1 to 57. Every student's going to be represented 1 to 57. I know 20 of them are on that sports team. So 1 to 20 are on the team, and that leaves 21 to 57 not on the team. So there's the numbers that we're going to end up using when we start running our simulation. Start calling up numbers. Okay? And if all 3 numbers are between 1 and 20, then yes, okay, all 3 were on the sports team. Okay? If any of the numbers are not, that means no. Okay? As long as one person's not on the sports team, we're going to write it down as no, not all 3 are on the sports team. Okay? In this case, you don't really have to worry about percentages, figuring it out, because we have objects here. Okay? These observational units are 57 people. That parameter of 80, that represented a percentage. Okay? 80% shooting, that represented a percentage. These values are actually representing people that can't get picked once or can't get picked twice to be in this dorm room. Okay? Now in this case, we're all 3 students on the varsity sports team. You're writing answers yes or no. Okay? This is categorical data. So at the end, when you're comparing these results, you're going to be finding a percent. Okay? Categorical data, you want to look at the final percentage, and then that's what we're going to compare to see, okay, is the fix on or not? Okay? So, quantitative data, find average. Categorical data, you find a percentage. Okay? Know the 4 pieces you're going to need to identify, and make sure you're thinking about the integers that you're going to use to run your simulation. Okay? So now's when you should probably practice a couple simulations and see if you get the hang of identifying your 4 pieces and selecting the right integers to use.